So at this point for Chapter 6, we have discussed multiplying and dividing rational expressions. And the next thing we need to talk about is adding and subtracting rational expressions. Remember, a rational expression is just a ratio of two polynomials. And with any ratio, when you're adding two of them together, you need to make sure they have the same denominator. For example, recall that 2/3 plus 4/3 gives you 6/3. I can just add the numerators because the denominators are the same. Then I can simplify this down to 6/3 is actually just 2. And same thing is true for rational expressions. If I have, say, x over x plus 1 plus y over x plus 1, then I can just add the numerators, x plus y, and the denominator remains the same. Never add denominators. I don't want to ever see that. Never add the denominators. The denominators have to be the same. So what if they're not the same? Then the first thing we have to do is we have to make them be the same. So we have to find the least common denominator. Remember, if you're doing this with a regular ratio of two integers, say we had 2/3 plus 3/4. Now the denominators are not the same, and we can't add them until we get them to be the same. So we need to find the least common denominator. That would be our step 1. Sometimes we refer to this as the LCD. In the case of 3 and 4, what is the least common multiple that we could put both of these ratios in terms of? The first thing you want to do is break your denominator up into primes. So first, factor the denominator, each one of them, into primes. Remember, a prime number is a number that can only be divided by 1 and itself. So if we factor 3, well, 3 is a prime number, so that has only two factors, 1 and 3. In the case of 4, though, that has more factors. The way we do this is we take our number to find all the prime factors, and we divide it by the lowest prime that we know will go into it, which would be 1, but then we'd still be left with 4. So we're going to divide it by the next lowest prime here, 2. And that leaves us with a factor of 2. So 4 equals 2 times 2. We could do this with this is more useful when we have larger numbers, like, for example, 24. Say I had 24, and I want to factor that into primes. First, I'm going to divide by 2. That leaves me with 12. Then I'm going to divide that by 2. That leaves me with 6, which is still also divisible by 2, which leaves me with 3, which is a prime. So 24 factored into primes equals 2 times 2 times 2 times 3. Those are all the prime factors that go into 24. Back up here, my prime factors for 3 are just 3, and for 4 are 2 and 2. So to put 2/3, I'll rewrite the problem down here. 2/3 plus 3/4. Put both of these in terms of the least common denominator. I know that my new denominator has to have at least one factor of 3. So I'm going to put that under both. And my new denominator has to have at least two factors of 2. Now in the case of this fraction here, I multiplied my denominator by 2 factors of 2. So I've got to do the same thing in the numerator to make sure that the overall value remains the same. And then over here, I multiplied my denominator by another factor of 3. So I've got to make sure I do the same thing up top. So I had my factor of 3 multiplied by the numerator, which is 3. Now, these can be added. So this is just 3 times 2 times 2, which is 12. That's the new denominator for both of them. 2 times 2 times 2 is 4 times 8 twelfths, and plus 9 twelfths. So now these can be added to give me 17 twelfths. And if I want, I can write this as 1 and 5 twelfths if I don't like improper fractions. But this is fine with me if you want to leave it as 17 twelfths. To do this with expressions now, with rational expressions, we have to do the same thing. So say we have something like, what's a good example? Say 5 over 6x squared y plus 3 over 4xy squared. So once again, we need to factor the denominators into primes. In this case, the prime factors of 6 are 2 times 3, and of x squared are x times x, and of y, it's just y. In this case, prime factors of 4 are 2 times 2. We have an x, and we have 2 factors of y that need to go in there. Okay, so for our lowest common denominator, we know that we need, from over here, we need at least one factor of 2. So I'm just going to start putting the factors in. So I need at least one factor of 2. I need a factor of 3. I need 2 factors of x, minimum. And I need a factor of y. Does that account for everything I need over here? Well, over here I see that I actually need 2 factors of 2. I've only got 1. I've got to put one more in. I need 1 factor of x. Okay, that's taken care of already. I've already got 2 factors of x. And I need 2 factors of y. Here I only have 1 factor of y, so I'm going to have to multiply 1 more in there. Now this is the denominator that we're going to put both fractions in terms of. All my prime factors are accounted for each denominator, and these two denominators are the same, so the numerators can be added. But whatever I multiplied my denominator by, my original denominator by, I still have to multiply the numerator by that same thing. Otherwise, these fractions would not be the same. But if I multiply the denominator by something and the numerator by that same thing, then that's an equivalent fraction. So down here, I multiplied my denominator, my original denominator, by another factor of 2. Okay, this 5 is my original numerator. So I have to multiply by a factor of 2 so that they cancel top and bottom. I multiplied by also another factor of y down here, so I've got to do that on top. Now over here for this expression, I have my 2 factors of 2, and then I multiplied by another factor of 3. So my original numerator here was 3. I'm going to multiply by another factor of 3 up here. And I have another factor of x that I multiplied by, and my y's are still what they originally were, so I don't have to do any y's there. So I'm just going to rewrite this a little more neatly. 2 times 2 times 3 is 12, x squared, y squared. And this will be the same thing over here. That's my least common denominator. And the numerators, let's see up here, this gives me 10y, this gives me 9x. Now the numerators can be added together. So I'll have 10y plus 9x all over 12 x squared y squared. There are no common factors in all of these terms that can be factored out. Therefore, this is already in simplest form, and we're done.